Hello and welcome to episode 1 of Bevy Basics. In this episode, I'll be covering the ECS. The ECS is the entity component system architecture that Bevy uses in order to break down game logic. The entity refers to an individual object in the world and is a unique identifying number. A component is a piece of individual data that can be grouped together via an entity in order to construct the world. A system is a function that runs on top of your components in order to make your game run. It also contains resources and events, resources being global collections of data that multiple entities may need to manipulate, but is shared between all entities. And events are a way for entities or systems to communicate with each other asynchronously. In my example I've got here, I have a unit component, which is more or less just a flag to be able to identify things and is very useful for queries. A struct that is holding a singular string and is used basically to store data. Then there's also a named version, which is basically exactly the same. To make a component, you literally just derive a component on a struct. I don't think there is any conditions at all. And you can also do things like derive whether it's a dense or a sparse layout, which is about optimization and efficiency. A resource can be any struct that I think derives default, I think is required. I think it's any struct. There's other conditions for implementing resources that require them to derive other from world and other functions like that, which are automatically implemented if it derives default. Okay, so here I've got a system which is basically just a raw Rust function with restrictions about what parameters can go into the function. In this one, I'm using components, which is a special struct from Bevy that lets you manipulate the world via commands. In this, I'm using commands to then spawn and then insert my component into the world. Like I'm spawning an entity and then inserting my component into the entity and then retrieving that entity and printing it into the debug, which is what you see down here is the result because I'm running it in the background. And then I'm also grabbing an entity and storing it as a resource. So I'm inserting resource target entity. This is so that I can acquire this resource later. As you can see, my target entity is the entity that I am storing. This is my startup system, which up here I'm inserting as a startup system up here. And then my logic, which will run every frame. So startup will only run at the beginning of the program. And then my logic will run every frame, and my other logic will also run every frame. Systems in Bevy are parallel if they have no conflicts with anything else and no requirements before they run. Systems can be chained together so that they run after each other in system sets or only when certain conditions are met, like maybe if a resource is present or absent or other systems like that. In this logic, I request the user's input as a resource, which is done by doing res. And I will go into more detail on this in the systems thing, in the systems video. But I basically request the resource of the user input, a query of all my components, and then also the resource of the target that I added earlier. I check the input if the user presses P, and then we'll print the data out. If the user presses T, I'll do the same thing, but only for the target entity. And down here, my other logic, which will run in parallel, is doing exactly the same thing, but only on the unit. This will result in Bevy having funny behavior, like if I press T, the order down here that unit appears is pseudo-random. It will be any order of non-conflicting systems, and because all these systems are non-conflicting and don't have any restrictions on when they can run, they may run in any order. I don't think there's anything else. So that is brief overview of the entity component system in Bevy, and is the system that you'll be primarily interacting with when you make games. I'll go into more detail on each of the individual sections in their own videos. So thank you for watching. Like, comment, subscribe, and I will see you